Hello everyone. Hello, Professor. I'll be presenting what we have done for our final project. I'll be starting with our libraries. We have used 30 libraries from the tidyverse package, which are dplyr, ggplot, vim, random forest, which is a different library, and also we have used catboost to build our model. To give some history on ggplot package, it was created by Hadley Wickham, and it offers a powerful graphics language for creating elegant and complex plots. It was originally based on a book called The Grammar of Graphics, which allows you to create graphs that represent both univariate, multivariate, numerical, and categorical data in a straightforward manner. So after having that said, we will be directly moving to reading our datasets. So our dataset is a CSV file, but separated by semicolon. So we will be needing this argument here in order to read it correctly. So to give a highlight of our notebook, we have four things here. The first thing is data pre-processing and cleaning. The second is explanatory data analysis. The third is modeling, and we have conclusion at the end. So to go over the first step, we will see the structure of data. So we have 224,868 rows and 47 columns in our data. And to have some overview of the structure or the data, we have some int values, character values. Even though they are dates, they are regarded as characters because of the codes. We also have some columns with null values. We will be taking care of them later on. And also we can see here that we have some question mark characters as a value for some of the columns. We will be looking into taking care of such errors later on our notebook. So the next part is we have added one more thing here, a string as a factor argument, in order to, because some machines or some platforms give factors instead of characters when you use read CSV file. So in order to be careful, don't forget to put string as factors most of the time. So we also have some overview of our data, some columns in rows. This is what our data looks like. So the first thing we did is to see the rows of missing data sets. So when we did that, we almost see that we have the entire data set displayed here. That might be because of some missing entries for the entire columns. So in order to have a full picture, we did a diagram showing that, and we can clearly see here that three columns don't have any entries, or they have like NA values in them. So the first thing we did is we have also here another plot to see which columns miss data. So the first thing we did is to get the names of our columns with missing values. So what we get here is birth country, legal status description, and scorecard description are three columns which have no data set or which have NA values in their entirety. So we used the select method from the dplyr package here to drop the three columns from our dataset. So we will be doing another overview of our columns for missing data, and you can see that none are missing for this time only. But on the structure of the data, we have seen some columns with null values as a string. Even though is NA does not detect them, we can see that they have null values as strings. So for example, we can see birthplace here to have null, and also some characters as entries. So we have to take care of those values by first replacing the null values with NA, and that will make it easier for its NA method to read them, and which is perfectly displayed here. We have residence country with 596 missing values, and we have some other columns with almost the entire rows missing values. So what we have done here is to get name of columns that have 50% or more missing values, which are displayed here: the extra nationality, profession, GIIN code, last update, and gender. What you see here is the index number, so you can use the index numbers to drop those columns. And we try to run the code again to cross check, which we didn't get any output, so we don't have missing values that are more than 50% of the data. So so we have to take care of our missing entries next, and in order to do that, we have separated our numeric columns and category columns into values you can see here. So we have the numerical columns here and the categorical columns here. So to see our list of missing values, we have displayed them here, which is obvious that most of our missing values are categorical columns. So there are many ways to take care of categorical missing values. So the first is ignore the whole observation, which we can do at this moment because we might lose some interesting observations or data that might be useful when building our model. The other one is replacing by most frequent value, which will be a good choice for us. We can also use some machine learning algorithms to predict those missing values or replace them, and we can also predict the observations using multi-class predictors. So as I've said before, we have used the most frequent values to replace our missing data. So there is this method that yields the most frequent values from our categorical columns, and we have replaced the missing values with the most frequent ones, or you can say the modes. And after that, we try to see if there are any more missing values in our columns, which is perfectly fine for us. And as also seen here, we have almost take care of our missing values. So the next step is to do some explanatory data analysis. So the first thing we did is to have the summary of numerical columns. So we have almost all numerical columns here. For example, to give some overview, is blacklisted have minimum value of 0, maximum value of 0, and it seems that most of the values are 0. This might be due to the fact that is blacklisted only have one data, which is 0. And the next one is RBA value, which will be our target value, and it has a max of 100, minimum of 4.08, and a mean of 17.62. So what we did next is to analyze the relationship between our dependent variables and independent one, and in order to do that, we have used correlation method to plot the correlation matrix here. But in this diagram, we can see that there are question marks here. This happens because is blacklisted value, as I mentioned before, have only one value, which makes the standard deviation to become 0, and that is kind of difficult to plot on the correlation matrix. And we will remove those both columns that have the same data and get our matrix plots again. I mean correlation plots again. So the other thing we did is some plots to analyze RBA value, and it is clearly seen here that our RBA value is kind of skewed to the left. We also have other scatter plots diagram to show relationship between our independent and dependent variables, and we also have density plots here to see the relationship between our two dependent variables, which is the RBA value and RBA grid description. and it can be clearly seen that lower RBA values have low RBA grade description, which is represented by the green density plot here, and higher RBA values ranging from almost 55 to 75 have higher RBA grade descriptions, seen clearly here. We have also other density plots, but we have found it hard to encode the output we see here because we didn't have that much information on the columns and the values they represent. So just to give some highlights, we can see here that ENU have higher densities on RBA values which are lower, and it is kind of good to see that pictorially, but you can't make any predictions or any sense of data since we don't have full information on what this categories mean. So what we did next is try to encode some character values that were integers, but they were put as characters inside a code. So for example, we have here creation date inside a code, which is supposed to be a date, but it is regarded as a character. There is also legal status code here, which is regarded as character even though its values are integers. So what we have done is encode those variables to have integer data types. After taking care of that, we try to find variables that are important to our target variable, which is the RBA value, using random forest, and we train with only using 100 trees and sample of our data, which is 5,000, and we can clearly see here that customer ID and full account have more effect on our dependent variable, but we know that customer ID is kind of a unique identification for all the rows, so we won't be having any important value on it for the model building. So the third part is model building. So we used the CatBoost model to build our to train our machine learning algorithms. So before that, we have loaded our CatBoost library here, and before that, before we train our model, we have encoded the second target variable, which is RBA grade description, 0 for low values and 1 for medium and high values. The other thing is to encode our categorical data inside that data. So after encoding those, we have training and test data sets because we need them for training the model and for validating our model. So 80% of the data will be for the training data set, and 20% of the data will be in the test data set. So we can see the summary of what the training and test data set here include, and we extract our target variables here, and after that we drop them from the training and test data sets. And the first thing we did is a regression model to predict RBA value. We have here the parameters for the CatBoost model, and these are the inputs for the CatBoost model, and this is how you train the CatBoost algorithm. So after a certain amount of time, the model finished training, and we have the prediction here, and when we calculate the error, we have RMSE value of 3.74. The second is the classification model, and after doing some training, we have an accuracy of 0.28. And as a conclusion, we have found that the data contains more missing values, and we can't drop most of them because they might have higher correlations, and more explanatory data analysis could be done if we have more information on column names and the data set, and our model could perform well if more parameter tuning is done. And this concludes our notebook, and thank you for listening. Have a great day.